also you must have some superficial idea in physics about vector equations of line and plane. So we know we have learned vector equation of line in coordinate geometry in different form. Similarly, what does it mean for an equation of line in vector form? First of all, we have to understand that. What is the meaning of a vector equation of line? In coordinate geometry, you have line y is equal to mx plus c, or in different form. So that means x and y are general points which will lie on this line. X and y must, all points which satisfy this equation, all pair of coordinates which satisfy this equation for a particular value of m and c will lie on this line. That is the meaning of this equation in coordinate geometry. This is the equation. X and y are general point. X and y are general point, and any point which satisfy this equation will lie on this plane. Will lie on this line. Or to draw this line, we have discussed how to draw the function. Put different values of y and find different values of x, or put different values of x 1, 2, 3, 4, 5 and find corresponding values of y, and we will get the points and draw those points on Cartesian coordinate system and join them. That is the equation of line. So that is the meaning of equation of line in Cartesian coordinate system. Then what is the meaning of equation of line in vector form? So in vector form, we get equation, a vector equation, whereas this vector equation is an expression. This vector equation is an expression, as this is an expression, scalar expression. This is not a vector expression. In vector equation, we have a vector expression where the position vector here x and y is the general point. In vector equation, position vector of a general point. Position vector is the vector of general point. So we find position vector of different points which satisfy the vector equation, and those points will form the line which is represented by vector equation. So this is very simple actually representation of line and plane. Let there is a line. This is x-axis and this is y-axis. So we will find equation of line passing through a point P and parallel to a vector B. So this is a point of P, that is A, B, C. This point is given and a vector is given P. So the equation of line in vector form means we will find position vector of a general point. Position vector of a general point on line. So let this is the general point Q. Its coordinate is x, y, z. As we find locus in coordinate geometry for a general point, similarly we find locus of this Q in terms of position vector in vector coordinate geometry. So we will find position vector of this general point which will represent vector equation of line. So this is O, this is vector OP, this is vector OQ. So we can say vector PQ is equal to vector OQ minus vector O. That is, let this vector is represented as R. This is variable vector, vector of general point. So this is vector R minus vector R minus vector OP. So this is vector PQ. So vector PQ lies on the line which is parallel to vector B. So we can represent vector PQ in terms of B. That is, let some constant into P. So equation of line will be R is equal to, let this OP vector is vector P. It is denoted as vector P, position vector of a point from which line is passing. P plus KB. This is vector equation of a line. Here R represents position vector of general point on line R, and P is a given point A, B, C, and B is a given vector parallel to line. So R is equal to, for different value of K is equal to, you can put K is equal to 1, 2, 3, 4. You will find different value of R because P and B are same. P is position vector of P, which is fixed. Sorry. And B is a parallel vector to this line, which is also fixed. B and P are fixed given vector. K is a variable. Put the values 1, 2, 3, 4. You will find different values of R. That is general point. So by finding different values of R, you can draw the line. This R is the position vector of those points. Joining those points, you will form this line. That is the meaning of vector equation of line. We will understand this with an example. This is origin. Let there is a line which passes through point P. So we will only focus on two-dimensional system I and J to make the problem simple. Adding K will not add any additional concept. It will only make problem complicated. So let there is fixed point 3, 5. Line passes through this point 3, 5, and this line is parallel to vector B is equal to 2I plus 3J. So this is a line which passes through point 3, 5 and parallel with vector 2I plus 3J. So vector equation, that vector equation R is equal to P plus TB, vector equation of line. It can be written as RP is position vector of given point. Position vector of given point will be 3I plus 5J plus T vector B, parallel vector to line, 2I plus 3J. This is the equation of line. Now to draw this line, put T is equal to 1, 2, 3, 4. You will get different values of R. So for T is equal to 1, R1, we will call it R1. For T is equal to 1, the R value of R is 5I plus T is 1, 8J. For T is equal to 2, R2. R2 is T is equal to 2, 7I plus 11J. For T is equal to 3, R3, 9I plus 14J. So in this way, you can put different values of T and you will find position vectors of points which lie on this line. So this is the position vector of point 5, 8. This is position vector of point 7, 11. This is position vector of point 9, 14. So these are the points on line, but we have found these points by putting t is equal to 1, 2, 3. You can find some more points by t is equal to 4, 5, 6, 7, 8, and these points will lie on this line. Just locate these points and join them. The line which you will get, that line is represented by this vector equation. That is the meaning of vector equation of a line. So that is vector equation of line. So we have seen that R is equal to P plus TB, where P is position vector of a point from which line passes and B is a parallel vector to line. So this is called parametric form. Parametric form of equation, vector equation of line. There is another form which is symmetric form. Symmetric form. To get the symmetric form, we get the equation of line in terms of x, y, z. So just put R is the position vector of general point, that is point x comma y. So R will be xi plus yj. Because R we have chosen a general point on line, general point, position vector of general point. General point is x comma y. So x comma y, position vector of point x comma y is xi plus yj. Put R is equal to this. So let P, a given point is, point P is given as x0, y0. This point is given from which line passes through. So position vector P is position vector of this point. So this will be xi plus x0i plus y0j. And vector B you need not to write. Vector B can be any given vector. So just put these values in this equation. Xi plus yj is equal to x0i plus y0j plus tb. Just transfer this to left side. X minus x0i plus y minus y0j is equal to, t is a constant, and let vector B is v1i plus v2j. So this is v1i plus v2j. So you can see, compare the coefficients of I and j. X minus x0 is equal to t v1 and y minus y0 is equal to t v2. So this can be written as x minus x0 by v1 is equal to t. Similarly, y minus y0 by v2 is equal to t. This can be written as x minus x0 by v1 is equal to y minus y0 by v2. This is parametric form of line. Parametric equation of line. So here point x0 and y0 are given, v1 and v2 and the vector is given. So this equation, symmetric form of equation can be derived. If we talk about R in terms of IJK, that is, then the same expression with same argument, you will have R is equal to xi plus yj plus zk. Point P is equal, position vector of P is x0i plus y0j plus z0k, and vector B is b1i plus b2j plus b3k. By the same argument, you will get symmetric equation as x minus x0 by b1 is equal to y minus y0 by b2 is equal to z minus z0 by b3. For three-dimensional coordinate system, the vector equation in symmetric form is written as this, where xyz is a general point, xyz. So we will take just an example, simple example, to illustrate the symmetric form of equation. That there is a line which passes through point P, and P is given as 2, 4, 5, and this line is parallel to vector B, and B is given as 3i plus 4j plus 7k. So this is the point from which line passes, and this is the vector which is parallel to the line. So symmetric form of line is x minus x0. x0 is 2 by b1 is 3 is equal to y minus y0 is 4 divided by b2 is 4 is equal to z minus z0 is 5 divided by b3 is 7. So that is symmetric equation of line, symmetric form, equation of line. So if equation is given in this term, this form, so if the equation of line is given in this form, so you can easily find that 3, 4, 7. So 3i plus 4j plus 7k is a vector parallel to line. 3i, 4j, 7k. 3i, 4j, 7. Just by if this symmetric equation is given and nothing is given, nothing else is given. By seeing the symmetric equation 3, 4, 7, this is coefficient of vector which is parallel to this line, and this 2, 4, 5 is coordinates of points which are from which line is passing. So this was vector equation of line in parametric and symmetric form. Now we will discuss vector equation of plane. Similarly, the concept is same. In plane also, we assume a general point, and the position vector of general point is represented as r, and the vector expression is derived in terms of r and given parameters for a plane. So a plane which passes through point P and parallel to vector B and C. For line, to define a line, we need one vector and one point. Then line is defined. Similarly, to define a plane, we need two vectors B and C. These two vectors, plane is parallel to B and C and passes through this point. Then plane is defined. So we will find the equation of plane. So this is plane. This plane is passes through point P. P is given, and this plane is parallel to vector. This is vector B, and this is vector C. These two vectors are given, and plane passes through vector B and vector C, as well as point P. So to find the equation of plane, we have to find vector equation for a general point in terms of its position vector, in terms of position vector of general point. Let a general point is this x. Position vector of x is represented as r. This is general point. This will move along the plane, and the coordinate of general point is x, y, z. Similarly, this is a point P, given point from which line passes. So similarly, r minus P, vector r minus vector P. This is vector r minus P. So you can see r minus P, B and C are in same plane. So vector r minus P can be represented in terms of vector B and vector C with suitable coefficient. Vector r minus vector P is equal to L. L is coefficient vector B plus M vector C. Any vector, any given vector can be represented in terms of two given vectors. Any vector, if you can imagine, this is vector A, and there are two vectors B and vector C. So by suitably adjusting their length B and C by multiplying coefficient L and M, their resultant can be equated with vector A. So vector A, this is vector A. So you can always find a parallelogram. Just draw, this is vector A, this is vector B, this is vector C. So draw a line from vector A parallel to vector C. Let this line cuts vector B having coefficient L. Similarly, draw line from A parallel to B on C, and it cuts vector C at length M. So you can see A is resultant vector by parallelogram law. A is resultant vector of LB plus MC. So any vector can be represented in terms of given two vectors by forming a parallelogram. So this A vector can be represented in terms of B and C. You just have to just complete the parallelogram, draw a line from A parallel to vector C on vector B, this line, and draw a line from A on vector C parallel to vector B. So this will be a parallelogram. This will be a parallelogram. So by parallelogram law, vector A is resultant of vector MC plus vector LB. L is the length where this line cuts vector B, and M is the length where this line cuts vector C. LB plus MC is equal to vector A by parallelogram law. So any vector, similarly this R minus P is vector in this plane. So this vector can be represented in terms of two given vector on this plane, LB plus MC. This can be written as vector R is equal to P plus LB plus MC. This is vector equation in parametric form for this plane. Here you can put different values of L and M, different combinations of L and M, arbitrary combination, and then you will find vector R, different vectors R. Then convert that vector in terms of coordinates, because R is a position vector. So corresponding coordinate for a given position vectors can be written. Locate those coordinates on this plane. So you will draw the plane. You can easily draw the plane as we have drawn the line in earlier example. Similarly, by putting different values of L and M for a given P, B, C. This is in vector form. P is the point P or L, M. So let us take a simple example. Let a plane passes through point P, which is 2, 4, 5, and vector B, which is 3i plus 2j plus 7k, and vector C, which is 2i plus 1j plus 2k. We have just taken arbitrary all these values. That doesn't matter. So this is the point 2, 4, 5. So the position vector of this point will be 2i plus 4j plus 5k. This is the position vector of this point P. So from this equation of plane will be P, position vector of point from which this plane is passing, plus 5k, plus L into vector B, 3i plus 2j plus 7k, plus M into vector C, 2i plus j plus 2k. This is the vector equation of plane. So when you will put different values of L and M, let I have put L is equal to 1 and M is equal to 2. So you will get L is equal to 1 and M is equal to 2. You will get a vector R. Let, for example, this R for L is equal to 1, 2. It may be wrong, but I am just writing. Let it is 5i plus 8j plus 9k. I have just arbitrarily written. You can calculate it properly if you want, but that doesn't matter here. I just want to explain the concept. So this vector is not actually vector putting L is equal to M and 2 in this expression, but we have assumed let R for L is equal to 1 and 2 is this. Similarly, put other combination L is equal to 2 and M is equal to 3, and the vector is let 7i plus 8j plus 9k. We have taken this arbitrarily just to explain the concept. These are not the correct vectors, just remember. Similarly, for different combination of L and M, let L is equal to 5 and M is equal to, you will get some other vector 8i, 10j, 12k. These are just wrong. I have already told you. So you have got different vectors. So these vectors are position vectors of general point x, y, z. So convert these vectors in coordinates of corresponding points for which these are position vectors. So the point for this vector is 7, 8, 9. Point for this vector is 8, 10, 12. So these vectors are position vector of these points. So just locate these points on Cartesian coordinates, join those points, you will get the plane represented by this equation. So that is the purpose, meaning of vector equation of plane, and that's how this vector equation represents a plane. This was parametric form of plane. This was parametric form of the equation of plane. Now another form is symmetric form. So we have got this R is equal to P plus L B plus MC. That is the equation of plane. Put R is one way, as we have done in equation of line. R is equal to xi plus yj plus zk, because R is position vector of general point, and general point is x, y, z. So this can be written as this equation xi plus yj plus zk is equal to, let P is a point having coordinate x, x0, y0, z0. So this is x0i plus y0j plus z0k plus m into vector b. Let vector b is b1i plus b2j plus b3k. Similarly, vector c is c1i plus c2j plus c3k. M into vector b, b1i, b2j, b3k plus c. So this was actually L, and this is M. That doesn't matter, these are just coefficients. You can put L there also and M here. That doesn't matter. M is c1i plus c2j plus c3k. So this is equation in symmetric form. X, Y, Z. So you know x0, y0, z0, b1, b2, b3, c1, c2, c3. In that case, you can find the equation of plane. That will be the equation of plane. And from this, you can see the equation of plane will have two values, constants. For different values of L and M, you will find different values of x, y, z. Put L and M and then find this expression. Compare the coefficients of I, J, K on left and right side. So you will find some point x, y, z. Similarly, put another pair of L and M. Then find this expression and compare the coefficient of I, J, K on both sides. You will find other values of x, y, z. So these both, you can find different values of x, y, z with different pair of L and M. So these points are nothing but points whose position vector is represented by R. These points will lie on the plane. That way you can draw the plane. So this is one of the form of symmetric equation, and other is very important form of equation of plane. Equation of plane which doesn't exist in case of line. So that is equation of plane in terms of dot product and cross product. So we know, same example, this is plane, this plane passes through point P, and this is parallel to vector B and vector C. So let, this is O, let a general point X, coordinate of general point, position vector of general point is R. Position vector of given point is P. So R minus P will be a vector R minus P, B and C. These all three vectors are coplanar vector. All three vectors are coplanar vector. So we have discussed earlier in triple scalar product, for coplanar vector, triple scalar product is 0. So these three vectors, triple scalar product will be 0. Can be written like this. Otherwise, simply you can say R minus P vector dot B cross C is equal to 0. These vectors are coplanar, hence parallelopiped, which will be formed with these three vectors will have 0 volume. R minus P vector, B vector and C vector. These are coplanar vectors. Hence this is equal to 0. It can be written as R minus P dot B cross C equal to 0. So it can be written as, where B cross C is a vector perpendicular to this plane. So it can be written as R dot n. N is B cross C. B cross C vector will be a vector perpendicular to this plane by definition of cross product. So R dot n is equal to P dot n. So that is also equation of plane in terms of dot product. R dot n is equal to P dot n. So let us take the form of this equation. What will be the form of this equation? This equation, when you will put, we will take an example actually. R, put R is equal to xi yj plus z. That is general point. There is n is a vector perpendicular to this plane, which is cross product of B and C, or it can be given directly. It can also be said that a plane passing through point B and perpendicular to vector n. That is also sufficient to define the plane. So let B cross C, two vectors were given. We found B cross C, and this B cross C we found vector n, and this n is n1i plus n2j plus n3k, and point P is x0, y0, z0. So just put these things in this equation to find xi plus yj plus zk dot n, n1i, n2j, n3k is equal to P dot n. P is position vector of this point. Position vector is x0i, y0j, z0k dot n, n1i plus n2j plus n3k. So this you will get in terms of n1x plus n2y plus n3z is equal to k constant. This is a dot product where n1, n2, n3 are coefficients, x0, y0, z0 are point. So dot product will be a scalar constant. So this is the equation of plane in symmetric form. n1, n2, n3 are components of vector n. Just remember, this is component of vector n, that is vector B cross C. n1, n2, n3, n1, n2, n3, and k is dot product of vector n and position vector of P. So if equation of plane is given as ax plus by plus cz is equal to d. So just by seeing the equation of plane in symmetric form, you can say ai plus bj plus ck. This vector is a vector which is perpendicular to this plane. By just seeing the equation of plane A, B, C in this form, you can find perpendicular vector, that is n, ai, bj, ck. So this vector is, just by seeing the equation of plane, you can find vector perpendicular to this plane, that is ai, bj, c, ai, bj, c. So that is equation of plane in symmetric form. This is also symmetric form for plane in terms of triple scalar product. So we will have some example to explain this equation of plane. Let there is point P, arbitrary point 2, 5, 7. Plane passes through this point. Let there is vector P I plus 2j plus 3k. Let there is vector C 2i plus 5j plus 7k. Plane is parallel to vector B and C and passes through this point. So we know the equation of plane is R minus P B C triple scalar product of R minus P B C is equal to 0. It can be written as R minus P. So there are two methods to solve it. So here vector P is position vector of this point, and this is 2i plus 5j plus 7k. So R minus P is R is xi yj zk. R is xi yj zk. So R minus P will be x minus 2i plus y minus 5j plus z minus 7k. This is R minus P. And there are other vectors B and C. Find the triple scalar product. It can be written as x minus 2, y minus 5, z minus 7. So triple scalar product, that is R minus P B C is equal to coefficients of B 1, 2, 3. 1, 2, 3. Now coefficients of C 2, 5, 7. 2, 5, 7 is equal to 0 because these are co-planar vectors. So just find this determinant x minus 2 into 14 minus 15 minus y minus 5 into 7 minus 6 plus z minus 7 into 5 minus 4 is equal to 0. It can be written as 14 minus 15 is minus 1, so it is 2 minus x minus 7 minus 6 is 1, so it is minus y minus 5 plus 2 minus 7 is minus 5, sorry, z minus 7, and this is 5 minus 4 is 1, so this is z minus 7 is equal to 0. So equation is 2 minus x minus y plus 5 plus z minus 7 is equal to 0. It can be written as minus x minus y plus z, minus x minus y plus z, and this is 7, 5 plus 2, 7, and minus 7, minus x minus y plus z plus 0 is equal to 0. 2, 5, 7 and minus 7 is 0. So this equation can be written as x plus y minus z is equal to 0. Equation of plane is x plus y minus z is equal to 0. So by seeing the equation of plane, you can immediately find normal vector, that is coefficients of x, y, z, that is 1 into I plus 1 into j minus 1 into k, that is I plus j minus, this is a perpendicular vector which we have discussed earlier. The equation will be in ax plus by plus cz is equal to d form. Parametric equation will come in this form. So ai bj ck is a vector perpendicular to this plane. So parametric form is in this form. So 1i 1j minus 1k is a vector which is perpendicular to this plane. But just seeing the equation, you can find this is a vector which is perpendicular to this plane. Equation of plane which passes through a given point P. Equation of plane passes through given point P having coordinates x0, y0, z0, and this plane is parallel to line which is given as r is equal to a plus tb. So this is equation of line, and this plane which passes through this point and perpendicular to this line. We have to find the equation of that plane. So we have one point, and from this equation of line, this vector is parallel to line, b vector. As the plane is perpendicular to line, so vector b is perpendicular to plane. So we have found a perpendicular vector and a point x0, y0, z0. Now we have to find the equation of plane. So we have seen equation of plane is r minus p. R minus p is a vector, and this b is another vector which is perpendicular to plane and parallel to line. So r minus p dot b is equal to 0, because b vector will be perpendicular to r minus p. That we have discussed this form as r minus p dot n is equal to 0. This form we have discussed, or we can say r dot n is equal to p dot n. This form also we have discussed, where n is perpendicular vector and p is given point. So this is same, b is the perpendicular vector and p is the point. So r minus r dot p is equal to p dot p. That is the equation of plane which passes through point P and perpendicular to this given line. Similarly, another case, equation of line which passes through point P and perpendicular to plane r dot n is equal to p dot b. Let this passes through point Q. A line which passes through point Q, and this is equation of plane. We have discussed this form. R dot n is equal to p dot b. In this equation, vector n is perpendicular to plane. So this vector is perpendicular to plane, and line is also perpendicular to plane. So line will be parallel to this vector. So for line, we have a point Q and a vector parallel to line n. This is plane, n is perpendicular to plane, and line is also perpendicular to plane. Hence, line is parallel to vector n. So we got a vector, a point Q. Let the position vector of Q is Q. So simple equation of line is position vector of point plus T n. A line which passes through point Q and perpendicular to this plane we'll have equation this. Similarly, distance of a point from a line. Let a line is represented as A plus TB. Here vector B is parallel to line and A is a point from which the line passes through. Position vector of that point. So this is the line. This is vector point. This is point for line whose position vector is A, and this is vector B which is parallel to line. Now another point Q is there. We have to find perpendicular distance from Q to this line. Perpendicular distance from Q to this line. So let the position vector of Q is Q, small q, that is so you can see Q minus A. Q minus A is this vector. This is Q minus A, and vector B is parallel to vector line. So perpendicular distance is, if this is angle theta, then perpendicular distance is mod of Q minus A sin theta. Mod of vector Q minus A into sin theta is perpendicular distance this D, mod of Q minus A to sin theta. So mod of Q minus A into sin theta you can write it as Q minus A, vector Q minus A cross vector B is equal to this theta of vector Q minus A with line will be same as with vector B also. This is theta and this is vector Q minus A. You can say Q minus A cross B is equal to, and mod of this vector is equal to mod of Q minus A mod of B into sin theta. Just divide both sides with mod of B. So this is Q minus A sin theta, and Q minus A sin theta is perpendicular distance D from point to line. So you can say this expression gives perpendicular distance from point Q, whose position vector is Q, from line having with which is parallel to vector B and passes through the point A. So we can say perpendicular distance is Q minus A vector Q minus A cross vector B, and mod of this vector divided by mod of B, and this will be mod of Q minus A sin theta, and this is perpendicular distance between given point Q and line parallel to B and passing through point A. Similarly, you can find distance from a point to a given plane. That there is a plane which passes through point A and perpendicular to vector n. So equation of plane is r minus A dot n is equal to 0. r minus a dot n is equal to 0. So let there is a plane, there is point Q. So plane passes through point A. Let us represent point A here, and this is coordinate system. So this is vector B, vector Q, and this is vector A. So Q minus A is this vector. N is another vector which is perpendicular to this plane N. So perpendicular distance N, perpendicular distance between Q and plane that we have to find. So we know that perpendicular distance from this point will be, let this perpendicular is false here. So this perpendicular and this perpendicular vector both are parallel. Both are parallel. So let this vector Q makes angle, sorry, vector Q minus A makes angle theta from vector N. So projection of this vector Q minus A on N will be perpendicular distance from Q to this plane, because this N is perpendicular. Just see separately, N is perpendicular to this plane, Q is this is Q, let, and this is vector QA, sorry, this is vector Q minus A. So you can shift this plane, this normal to here also. Angle between normal and Q minus A is theta. So projection of vector Q minus A on N, that is this length is perpendicular length, that is you can draw perpendicular from here also. So both these lengths will be same. So this perpendicular length is nothing but projection of this vector on perpendicular vector, which is N. So you can say Q minus A cos theta. Q minus A cos theta is projection of vector Q minus A, sorry, this is mod, vector Q minus A on vector N. So Q minus A cos theta is perpendicular distance, which is projection of Q minus A on N. This is perpendicular distance. So we have to find this. So this can be written as Q minus A vector dot N divided by mod of vector N. If you will explain this, this is mod of Q minus A, mod of N cos theta divided by vector N is equal to mod of Q minus A cos theta. So this expression is perpendicular distance between this point and plane. This will give Q minus A cos theta, and Q minus A cos theta is nothing but projection of vector Q minus A on vector N, which is perpendicular to this plane. This is Q minus A cos theta. So this is perpendicular distance from point. So for this vector, N is perpendicular vector, this is known, A is point is known. So we will just have an example to illustrate this, that there is a plane which passes through point 2, 5, 7, and this plane is perpendicular to vector N, which is given by 2i 3j plus 4k. So this is plane 2, 5, 7. This passes through this point and perpendicular to this vector. Now we have to find distance of this plane from point 7, 8, 9. For example, so this is point Q. So equation of plane is R minus A. A is point from which point is passing. So vector A is 2i plus 5j plus 7k. Vector Q is 7i 8j 9k. Q means position vector of point Q, from where we want to find perpendicular distance of plane. So vector Q minus A. Vector Q minus A is equal to 5i plus 3j plus 2k. Q, vector Q is this. So perpendicular distance from point Q to plane is equal to Q minus A dot n by mod of vector which we have derived earlier. So it can be written as Q minus A is 5i plus 3j plus 2k dot n. Perpendicular vector is 2, 3, 4. 2i 3j 4k divided by mod of vector n, that is under root 2 square plus 3 square plus 4 square. So this can be written as 10 I dot I and I dot j and k is 0. So I dot I and 5 into 2 is 10. Similarly 3 into 3, 9 plus 2 into 4, 8 divided by under root 2 square is 4, 3 square is 9 and 4 square is 16. So this is 18 plus 9, 27 by under root 25. So this is perpendicular distance from this point Q to plane, where Q is this point and this plane passes through this point P and perpendicular to this normal vector. So this is very simple example. So these are the methods to find equation of plane, equation of line, distance between a line and a point, distance between a plane and a point. Or we have discussed a plane which is perpendicular to a line and passing through a point, or line which is perpendicular to a plane and passing through a given point. So in this way you have different combinations. You can solve these problems in different combinations. So these are just basics of vector equations of plane and line. So we have discussed equations of plane, triple scalar product, equations of line in parametric form, in symmetric form, and their operations, distance from points, etc. So you will not directly get this problem, such problems to find the equation of plane or line, but in problem it can be mentioned this is equation of line in vector form, this is equation of plane in vector form. So you must have familiarization with vector equations of line and plane to solve physical problems given in terms of vector form of line and plane. So that was our today's discussion.